Today we are going to discuss problem of points on side views. Okay, so in this problem, so we will be dealing with the side views here. So we will go with the question. A point P is lying. P is 30 mm in front of VP, 40 mm above HP, and 50 mm from RPP. Okay, so in this problem, so as we have know, so it involves three concepts. First, to identify the quadrant. So in front of VP, above HP means it is our first quadrant. So for the first quadrant, we know the notations. So VP, HP, XY. That means first we are going to draw the this first quadrant, top view and front view. Okay. Okay. So we know that 30 mm in front of VP means it is in front of VP means it is top view. So top view it is drawn in the HP plane. So 30 means 3 boxes, and you put a point. So that is here the top view. Similarly, 40 mm above HP. So 40 mm above HP means it is our front view. It is 4 boxes. It is P dash. So now we'll show with the dimensions. This is 40 mm and this is 30 mm. Now you can see this 50 mm from RPP. This is what the side view. So where it is exactly means in the quadrant. So you can see this. So this is our HP plane and this is vertical plane and this is our RPP, right profile plane. So this right profile plane, it is adjacent to the vertical plane. Okay, so in this problem he is mentioning that a point P is 30 mm in front of VP and 40 mm above HP and 50 mm from the RPP. So this it will be there adjacent to the vertical plane. Okay, when it is drawn in the orthographic, so it will be like this. Okay, so front view, top view, this front view connected with the side view. Okay, so that means for this RPP we will be drawing another x1 y1 line at a distance of 50 mm. Okay, now to draw this side view with the top view, we will be using 45-degree angle line. Okay, so you just follow the procedure. Okay, now from this projection point we have to consider a distance of 50, that is 5 boxes. Keeping this distance of 5 boxes, here we are going to draw x1 y1 line because it is 50 mm from RPP. So this is x1 y1 RPP, right profile plane. Okay, now we know that so side view will be there adjacent to this front view. So we draw a straight line. After this we know that we have to draw an 45-degree angle line here. Okay, in order to connect the top view with the side view. So that is 0, 10, 20, 30, 40, 45. So mark a point, then draw a straight line. This is your angle line, that is 45-degree angle line. Now from this top view, so you will be drawing a straight line until it touches the 45-degree line. Then we project upward. Okay, so where these two lines are intersecting, so this point is our side view. Okay, this is what the say, and we can show the direction of the projection line. Okay, so this is what the side view. So today in this problem we construct a pentagonal pyramid with respect to slant triangular face. So the same thing can be demonstrated using SolidIt software here. I'm constructing a pentagon using polygon by center here. Draw the perpendicular bisectors here. After writing down the notations, we should draw the projection lines here. Okay, copy down this and using a move command, and then slide along the XY line and then select these heads. So however it is there in the solution book, I'm following the same procedure here. Now project downward to complete the second position top view here. After drawing the projection lines, write the notations. And mark the notations. Okay, after marking down the notations, the concept here it is same. First you have to draw an outer boundary line, then the visible edges in the visible faces, and then finally the hidden edges in the hidden faces. Okay, so first I'm constructing an outer boundary line. Here from the top face, so pentagon it is visible, that's why continuous, and A dash 2 also continuous AO. Okay, but the triangular face DO and C not visible, that is written with the dashed line. And axis we have to show. Now draw an angle line for 45 degree, that is minus 45. Select the second position diagram using move command and place it with respect to the axis. So project the lines to complete the final position. Third combination of cylinder and rectangular block. Okay, so to construct here, first we need to take one horizontal line as a reference. From this reference point, I'll draw one line, that is line with an angle of 30 degree. So here I'll take 60 mm. Okay, and angle will take 30 degree because in isometric we should use angle 30 degree. Okay, first I'll be constructing an rectangular block. Okay, so here the rectangle block having base sides 30 mm 30 degree and vertical edge 60 mm, angle is 90 degree. Again length is 30, angle is minus 150, and then vertically downward is joined with a length of 60 mm. Okay, now we have to give the width here. So width of 30 mm at an angle of 150 degree. Okay, so the same line I'm going to transfer it using move command, creates a copy, then place it like this, so it will reduce your effort. Okay, now complete it, so the rectangle block will be over. Okay, now we have to draw the cylinder. So cylinder, it is there exactly at the center of the block, so the total length it is 60, means we need to subtract by 15 mm. So just see, so watch the video till the end, you can understand. So vertically downward by 15 mm, I'm coming downward 15, 90 degree, and then 30 mm, then angle of 150 again here. Now the length required for the box, it is 30. Okay, again horizontally. So this is the box we require to construct the ellipse here. So from this corner point to the midpoint. Okay, again from this corner point to midpoint. Okay, from this corner point to midpoint. Okay, from the corner point to the midpoint, you can select the line. So now using for arc by center method, that is using arc by center method. So here we will be constructing an arc here to construct the ellipse, taking this length, draw an arc. Same way from here to here, take this length, draw an arc. Now for the third point, okay, take this as a reference point, taking this length, draw an arc. Okay, and same way here also, take this length and draw an arc. So we have completed an ellipse here. Same way we need to construct another ellipse at a distance of 60 mm. For that, as a reference, I'll be considering a length of 60 mm, and then another box of ellipse I'll construct. Okay, for a reference I'll be taking this length. So length of 60, angle minus 150. Because we should be extruding at a distance of 60 mm, right? That's why I'm considering this length of 60, angle minus 150. Okay, from all the four corners of the box I'll be extending the same length 60 mm, and angle is minus 150. Okay, okay, now here we got the endpoints. Here we need to construct a box here. Okay, subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. So it is important, guys, you should go through all these model question paper. There may be chance you can get the same questions for the exam, because the question paper, it is coming from the VTU. So make sure you go through all the problems, because we don't know which problems may be coming for the exam. Okay, in each model we have 50 different questions. Okay, just go through my videos wherein I have explained the problems with all concept with less time. Okay, guys, make use of the videos, and during the exam time it is very helpful that you can revise this subject using my videos. Okay, because you may be forgetting all the concept, because the practical exam, it is there after 1 month. Okay, so draw a diagonal line. Okay, now join from this end to this end. Again, join from this end to this end. Okay, so now we need to make these lines as thick lines. Okay, so rectangular block also I'll make thick by selecting all the edges. Thank you all. Thank you for watching my video. Subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. This, okay. First we draw an parallel line here. After that we'll draw one vertical line. Okay, vertical line we draw here. So vertical line, after drawing it, so it is hexagonal prism, so that means it has to be so set with the using offset command. So I'm going to construct it. You can see this is cut, so that means the front and top view will be given in the question. So we need to draw only the development for this. Okay, so vertical line drawn. Now using offset command, I'll be offsetting this vertical line for a distance of 20 mm. There are total 6 faces I will consider here. Okay, 6 faces we are considering it. You can mention the naming for it, each of these vertical edges. Okay, that is capital A, capital B, capital C, capital D, capital E, capital F. I mention EF and A, and now we have to mention these cut points here. So cut points, that is with respect to the section plane, we are mentioning 1, 2, 3, 4 here. So we have to draw an horizontal line, say from this end, and draw an horizontal line. So that is our 1. So we get it on the vertical edge here. That is 1 and 1. Okay, same way, so the projection of horizontal line from 2 till B. Okay, that is your point number 2. Okay, now projecting the point number 3 horizontally till the vertical edge C here. Okay, now point number 4 exactly falling on the corner point of the vertical edge D here. So we can mention that is 4 here. And point number 5, it is the extension of the point number 3. So we have to extend that horizontal line from that point 3 till the vertical edge G here. So that is your point number 5. Okay, now the same way we have extended the 2 to get the 6 here. So actually at the vertical edge it has to be 1. So you can change it. So now I am rewriting it correctly. So that is our point number 5. Okay, and that is point number 6. And now here we are getting the point number 1 here. Okay, now the same way for the bottom faces also we have to draw an horizontal line here. Okay, you can see that the point number 7 on the vertical edge. It is having on the B here. You can see that. Okay, So point number 7 we are getting on a vertical edge B here. So that is your point number 7. And point number 8 you get it on the vertical edge of C here. It is falling on the same vertical edge C. Okay. And point number 9 is on the same vertical line 1 here. So we can draw an horizontal line, or we can show it on the horizontal line of 1. So I'll be drawing it so that it will be convenient, that will not get confused here. Okay, that is point number 9. And the same way we have to mention the point number 10. Point number 10 falling on the vertical edge E here. Okay. Point number 11 we get it on a vertical edge 7 here. So just I am projecting using extend to next command. I am getting that point. Okay. So that is your point number 10 here, and using extend to next we get the point number 11 also. Okay, that is your point number 11. Okay, so now we can join all these points with a straight line. You can try to connect it. Okay, you can zoom in and connect. Okay, zoom in and get the exact point here. For that you can zoom. Okay, zoom in, zoom out. You'll get the exact points here. Okay, now it is connected. You can see that. Now the only the cutted part we have to make it dark, then the other part we have to make it thin. So for that we will be using split command. By selecting it we are going to make those lines as thin lines here. Okay, using the split command we can show the remaining part in a thin lines. So you can select those lines and make it thin here. So you can subscribe for the channel and hit on the bell icon for the latest notification of this engineering visualization subject, and share it to the maximum students so that they can be benefited. Hit the like button and share it to the maximum students so that they can be benefited. So by selecting it, we are making this as a thin line. Okay, so you can see that this completes the problem here. Good morning. We will see another different type of problem in triangular lamina. Okay, in this type of problem, you see it, we have to construct a triangular plane lamina of dimension 25. So resting on HP and with one of its corners touching on it. So the first position we know it, we have to construct a triangle with the corner on the HP plane. Now you see it in this problem, we have mentioned such that the side opposite to the corner, okay, side opposite to the corner on which it rests is 15 mm above HP. Okay, instead of giving angle of inclination, they are giving some sentence here, and then makes an angle of 30 degree with VP. So we have only one angle of inclination given, that is angle of inclination to VP. Instead of angle of inclination to HP, they have mentioned this sentence. Now we will proceed with the sentence. As I'm proceeding, I'll be explaining. So what it is. Okay, how we proceed with the second position. Okay, so we have to construct a triangle of dimension 25. Okay, with respect to corner, we have to construct this. Okay, so this is A, B, C, and it is having a dimension of 25. So we have to show the dimension here. Okay, the front view, we get it on this XY line. Okay, this is A dash, B dash, and C dash will be in bracket. Now you see this question, they have mentioned only the distance here, and they have not mentioned how much angle of inclination. Instead of they have mentioned only this sentence, that is the side opposite to the corner on which it rests is 15 mm over HP. So this is what the side which is opposite to the corner. So what happens in this second position is we are inclining this side at a height of 15 mm above HP. So inclining at a height means we are inclining this front view only, right? So what we do, so first I will take a reference point A dash at a height of 15 mm. Okay, at a height of 15 mm, will mark a reference point, and then I will draw here locus line. Okay, locus. Okay, so after this what I will do, after marking 15 mm height here, so you can show the dimension here on one side. So it is 15 Okay, after drawing we have to measure this length, okay, from this reference point, so you can cut the arc. So this is B dash and C dash, so you can join this. Okay, so by joining this, so we can able to find out how much angle it is. The angle of inclination here we are getting around 40, but we have to get 44 here. I'm getting 41 degree. So projecting downward, this is A, this will be B, this will be C. Okay, now the angle of inclination to VP already they have mentioned, so we can do it reference point. So here, so you have to mark at 30 degree. Mark at 30 degree. So we have to take this reference point C from C to B. Look at the one arc, that is CB. Now we have to transfer this diagram, right? So this is here. So by projecting upward, can complete the final position. So here we get it here, A dash, C dash we are getting here, and B dash we are getting here. So join it. So this what completes the problem. First we take a reference line. Okay. So from this end, construct. Okay. 60 length, okay, angle 30. Okay, next it is vertically downward by 15 mm. Okay, so downward 15. Okay, again here 30, angle 30. Okay, and vertically upward 60. Okay, and then here in this direction again it is 30. Again vertically downward 15. Okay, again here 60. And then finally 60 is angle 150, not 150 minus 150. Angle 60 minus 150. Now we have to give the thickness here. So thickness of 30 we have to give. This end 30, angle we have to give 150. Okay. So after this, we have to create a copy, selecting from this end. So now after this, I'm going to select this side view. A copy this end the join. So finally we are going for the trim. So you can see this completes the problem. So finally we have to convert into ISO. 0.816. So this completes the problem. Welcome to Engineering Visualization channel. Okay, today we are going to see problems on points problem. Okay, so as we have discussing the problems on points, okay, so it is one of the different type problem. You can see in this problem they have not given any kind of dimensions. Instead of it, so using the concept we have to solve the problem. Okay, you can see the question here. Draw and state the quadrants in which the following points are located. Assume any distance. That means the distance you can take any of it. Okay, you have to identify which quadrant each of these points are locating, and then you have to write it by assuming any distance. Okay, so you can see front view below xy line and top view above xy line. So it is third quadrant, right? So I'll write here only. It is third quadrant. Similarly, front view and top views are below xy line. So this is fourth quadrant. Okay, front view and top views are above xy line. It is second quadrant. Okay, front view above xy line and top view below the xy line means, so it is your first quadrant. Okay, so it is easy to write. So first I am going to draw one xy line here. Okay, so here they have not mentioned to take exact distance, so conveniently you can take any of the distance. Okay, first I'm mentioning this, the point here. Okay, front view below xy line and top view above xy line. So front view below xy line means this, I'm taking convenient distance and I'll put a point. So this is a dash. Similarly, this is a top view above xy line. Okay, this is your third quadrant. In the same way, leaving convenient distance, front and top views are below xy line. So I'll be mentioning here. Okay, both on the same line. I'll mention B dash. Okay. Next, front and top views are above xy line. So above xy line means I'll give one as 30 and another will be on 40. So here C and C dash. Next, fourth line, that is a point number D, front view above xy line, front view. So here I'll mention front view. This is D dash and top view below the xy line. So here it is. So here we have assumed any of the distances. You can assume it. It is given in the question. Okay, so that completes the problem. Okay, you can mention, if you want to mention, you can mention here. A is in third quadrant. Okay, and B is in fourth quadrant. Okay, similarly C is in second quadrant and D is in first quadrant. Okay, so that completes the problem. You can subscribe for the channel and hit on the bell icon for the latest notifications and share it to the maximum students so that they can be benefited. Thank you all. Thank you for watching the video. horizontally on a rectangular slab of sides 100 into 60 and thickness 20 mm. So draw the isometric projection of the combination. First I'll be constructing a rectangular slab of 100 into 60 and I'll give thickness of 20. Okay, take a reference line. Okay, give the length 100 and take angle 30 degree. Again give the length 60, angle 150. Okay, again length 100, angle is 210. Then join. So give the height 20 mm, here thickness 20 mm. So give the length 20. Okay, go to copy, create a copy, select the end point and place it exactly on the corner points. Select the bottom face, go to move command, create a copy and place it. So rectangular slab is done. Now we have to construct an rectangular pyramid of dimension 40 into 25. So on the 100 mm side I'll be cutting at 30 mm radius by taking 30. Okay, 100 minus 60 means you will get 40. So go to arc by center from the end point. So here we have to give 30. So give the radius 30. From this end also you can type 30. Okay, the other side it is 25. So 60 minus 25 means it is 35. So 35 means 15. So 15 means 7.5 we have to cut on either side. Okay. So this is we are constructing using subtraction of box method. Okay, now we got a rectangle of 40 by 25, so we'll join with the thick line. I will be drawing the two diagonals to find out the center of it. So from the center I will be drawing an axis line for a length of 50 mm. Vertically 50 mm I'll consider. Okay. Okay, so this welcome to engineering visualization. Today we see a funnel problem. So here in the question, funnel is made up of sheet metal. The funnel tapers from 60 to 30 mm diameter to a height of 25 mm and then forms to a cylinder with a height of 50 mm. Bottom of the funnel is beveled off completely at an angle of 45 degree to axis. Beveled off means we need to cut it with an angle of 45 degree from one of its corner. So draw the development of the funnel. Okay. So step by step we are going to do. First we are going to construct the top part of it, that is funnel made up of top diameter 60 and the bottom 130. So tapered section I'm going to do it first. Okay, so mark a length of 60 mm using scale. Okay, now vertically downward the height we should consider, that will be 25 mm. Okay, from the center of the line I'll be drawing vertically straight line downward at a length of 25 mm, that is 2.5 centimeter from the scale. Okay, now from this midpoint, so the bottom part we required that should be 30 mm. So this is exactly 60. From the center we have drawn a line. Okay, from this center we will be drawing 30, means here from the center I will be considering 15 on both sides. Okay. Okay, now we join it. So this is the tapered section of the funnel. Now you can show the dimensions. So the top part having 60 mm diameter. Okay guys, this is my 700 video. So I'm very much thankful for my viewers for their continuous support. Okay, so after showing dimensions, so the height also I'll show. The height is 25 mm. Now the lower part, it is a cylinder. Okay, cylinder with a height of 50 mm. So funnel it is done. Cylinder of height 50 mm. Okay. Can show the dimension for it. It is 50 mm length. Now we need to cut this lower part of the cylinder at an angle of 45 degree. You can see the question. So bottom of the funnel is beveled off completely at an angle of 45 degree to axis. Okay, that is from one end. So we need to draw an angle line, and that should be at an angle of 45 degree. So take the protractor. Okay, mark to the one of its corner end. Yes, we should be marking one of corner end. So mark an angle of 45 degree. Okay, now draw a section line, cutting it to show it section line. I'll be using different sketch pen. Line dot line. Okay, so it is exactly cutting at an angle of 45 degree. Okay, now we need to construct the top view of this cylinder. Okay, in order to show the cutting, it will become very easy. Okay, so the upper part of the funnel, right? So when we construct it will not possible, so we will extend it to make it look like an cone. Okay, so construction of the cone, we know using the formula small r by capital R into 360 degree. We can do that. So just extending that. Okay, tapered part, so it will be easy for us when we do the development of it. Okay, so I can measure this dimension, how much it is. So it is around 60 or 62 mm. 62 mm. How much you are getting it, you need to draw for the same length. So in order to understand this problem completely, guys, you need to watch it till the end. Okay, so you can understand all the steps. So now we will be constructing the top view of the cylinder. Okay, because in this problem the cylinder has been beveled. Beveled means cutted, so that means we will be constructing only the top view of the cylinder. Okay, so here the cylinder having a diameter of 30, so I'll be taking compass. The radius will be 15 mm. 15 mm means 1.5 centimeter from the scale we need to measure. Okay, draw a circle. So we need to project that axis downward and then we should consider the center. Here I am taking directly the center point of it. So you need to project downward that axis and then take the center point and draw a circle. Okay, so after drawing the circle, so show the dimension. So here we will be cutting this, dividing this circle into 8 equal parts. Okay, diameter 30. So in order to divide into 8 equal parts, we will be using an angle of 45 degree. So using the protractor, we can do it. Okay. So mark angle 45 degree, 90 and 135. Okay. I think the points you are not able to see it properly, so I'll be using the sketch pen so that you can get the exact points. 45 degree here, guys. 45 degree, 90, 135 and 180. After marking it, you can extend, right? Using the scale we can extend from the center point, merging it and draw the line. Okay, now it is divided, so you can give the naming for these cut parts: A, B, C, D, E, F, G. Okay, now we'll just project it upward so that we can write the top and front view notations. Okay, here I'll differentiate this top and front view, okay, with XY line, so that we can able to clearly understand it. So top and front view in this problem, guys, we are starting from the front view and then finishing up the top view. Okay, the problem is like that only. Usually we start from the top view, but in this problem we started from the front view. So draw the projection lines. Now write the namings. So here A dash, B dash, C dash, D dash and E dash visible. H dash, G dash and F dash are not visible. Those are written within brackets. Okay, now we need to write the cut points. Okay, so here so cutting exactly line 1, 2, 3, 4. You can see wherever the section plane is cutting, right? So we are writing again here 6 it is, this is 7 and this is 8. Okay, so part by part we are going to do the development of it. Now we have done the cutting also. Okay, step by step we are going to follow it. Okay, this is the funnel and this lower part is the cylinder. So step by step we are going to do it, guys. So watch it till the end, you can understand all the steps. Okay, this is one of the, you can say, the application problem. The first we are doing it is cylinder. Okay, the cut portion cylinder. So here for the cylinder we have the formula pi d. Okay, pi into diameter here it is 30. Okay, diameter of the cylinder is 30. So the length what we get, that is 94.24. so this cylinder will be done using parallel method. So I'll be using here two parallel lines, here x from this end and also from this end. Okay, so I'll be considering one vertical line. So the total length we should be considering, that is 94.24. So mark 9.4 here. 9.4. Okay, now we need to divide this 94.24 into 8 equal parts. Okay, the thing can be done by using measuring the compass. You can measure the length from this top view circle. Okay, measure this length and cut the arc. So it will be equally divided. Okay, this is A, B, C, D, E, F, G, H and A again. Okay, use the scale properly, guys. You need to draw straight vertical lines. Okay, now the marking the cut points on this development, it is easy. Just draw horizontal lines from those cutted points. From one, just place the scale like this and just draw horizontal line. Okay, from the point 2 also you do the same thing, and from 3 also the same thing. So this cylinder and prism will be constructed in the same manner, guys, because all the cut points are occurring at these vertical edges. So no need to measure, just draw the projection lines and then now you mark. This is the point number 1 here, and even here on the vertical edge of A. Now it is 2. Okay, 2 on the vertical edge B and 8 on the vertical edge H. Same way 3 on C and 7 on G, and then 4 on D and 6 on F, and then 5. Okay, now we need to connect it using the curved line because this is a cylinder. Okay, with the help of color sketch, this is what we need to connect. So using the curve you need to join. Okay, don't use the scale here. Okay. Okay, so guys, this completes the cylinder. So I'll be showing the dimension. So this is the development part. Okay, development of this beveled cylinder, that is a cutted portion of the cylinder. Now we need to construct the funnel. Okay, funnel, we will be constructing a funnel using this cone method. So for this we have the formula. Okay, funnel, it is resembling the cone. We have the formula small r by capital R into 360 degree to find out the angle of inclination here. Okay, first I'll be finding this slanted edge length. So slanted edge length, it is 62, and that upper part, okay, upper part which is visible to us, that will be around 22 mm. I think 29 mm it is, sorry. Okay, so capital R, it is 62, that is slanted edge length, and diameter D is 60 mm. So that means R means radius will be 30. Okay, because we need to use this formula in the construction of the funnel. That is small r by capital R into 360. So capital R is your slanted edge length, small r is your radius length. Okay, substituting the values. So and then the angle we need to calculate using the calculator. Here the angle we are getting, it is 174 degree. Okay, so capital R we know it is slanted edge length. So I'll be drawing one horizontal line for a length of using compass, or you can draw a straight line also. So take 62 mm and draw an arc here, curve here. Okay, some semicircle type we need to draw, because here the angle it is 174 degree, right? So now you can join this. This is having an angle length of 62 mm. You can mark. Okay, so that is your slant edge length. Capital R. Okay, so the angle we need to mark here, it is 174 degree. Okay, that is our angle. Guys, so subscribe to my channel and hit on the like button, and for notifications related to engineering drawing you can click on the bell icon. You'll get all the notifications related to the Vtu engineering graphics, or you can say the computer aided engineering drawing. Okay, now complete the arc. Okay, now here the length we should be drawing, that is the visible part of that funnel, that is 29 mm we need to mark. Okay, guys, this is my 700th video, so thank you for your support, so that I can grow my channel. I wish my channel may reach 1 lakh subscriber by another 2 or in within 2 to 3 years. I hope so. Can cut the length, that is 29 mm. Okay, so okay, this length we should be darkening it. So I'll be using different color chalk here, sketch pen, so that you can make out the difference Okay, this is the upper part of the funnel, right? That's why we need to show the lower part here in this development. Okay, guys, when you're going through my channel, if you're finding any difficulty in understanding, you can ask me your queries, doubts through comments, or you can mail me. I've given my email ID in the YouTube channel and my WhatsApp number also. So any doubts related to any of the videos, you can WhatsApp me or you can email me so that I can help you. Okay, share these videos to your classmates and friends so that they can be benefited. So guys, thank you all. Thank you for watching my video. So this is the development of the upper part of the funnel. Okay. So now you can see in this video both the things are done. So lower part of the cylinder also done and upper part of the funnel also done. Thank you guys. Thank you all. Thank you for watching my video.